So the next pair of sides that I'm going to compare are EF to ML, and I'm going to go into the diagram and look at what side lengths they have. So EF is equal to 15, ML is equal to 25. If I take out the common factor of 5 from the top and the bottom, I also get a ratio of 3 to 5. I want to compare the last pair of corresponding sides, which would be GF to NL. I'm going to look in the diagram and see what side lengths they have. I'm going to take out the common factor, which would be 6. And I also get 3 to 5. So all corresponding sides simplify to the same ratio of 3 to 5. So yes, they are proportional. So we would say yes, the two triangles are similar to one another. So in the next example, we know that triangle MNP is similar to triangle XYZ. I want us to find the value of X. We are going to have to set up a proportion that compares corresponding side lengths to one another. I sometimes think that the easiest way to set up the proportion is to write the extended proportion comparing corresponding sides, like we've been doing on the last several examples. So I know that, this should be an N. I know that MN corresponds to XY. And that ratio should be the same for all the pairs of corresponding sides. So NP corresponds to Z, and then MP is going to correspond to XZ. And again, I'm coming up with this extended proportion just based off of the order of the letters in the similarity statement. What I'm going to do now is go into the diagram and record side lengths and expressions in for all the sides that I have. So the first one, MN, I have nothing there. Nothing. If I look at XY, that's equal to 55. NP is the 4x minus 10. YZ is 75. MP is x plus 5. XZ is 30. So I want to figure out the value of X. So this first ratio isn't helpful to me because I have no idea what MN's length is. So I'm going to set up this proportion and solve this proportion for X. We went over solving proportions in the last video. So what I'm going to do is I'm going to cross multiply in order to solve. So I'm going to multiply 30 by 4x minus 10. That's one cross product. I'm going to multiply 75 by x plus 5. When I start to distribute, I get to this equation. If I subtract 75x from both sides, I'll get 45x. If I add 300 to both sides, I'll get 675. And if I divide by 45, I will get x is equal to 15. So for examples like this, I really recommend writing out the extended proportion, filling in the proportion then from the diagram with the given sides and expressions, and then using that to figure out what two ratios you're going to use to set equal to one another in order to solve for the variable that you're looking for. What we're going to be talking about next are two different vocabulary terms that are synonymous to one another. They mean the same thing. So similarity ratio and scale factor. So the ratio of the corresponding sides, what we've been setting up, the ratio of the corresponding sides, is called the similarity ratio or the scale factor. So I give you a similarity statement. I tell you that triangle ABC is similar to triangle XYZ. And then I have two fill in the blank sentences. So AB does correspond to XY because they're the first two letters in the similarity statement. But the two sentences differ in the way that I've written the triangle. So the first sentence says the scale factor of triangle ABC to triangle XYZ is blank. So when I'm going to write this similarity ratio or scale factor, I want to make sure that I'm taking a corresponding side of triangle ABC, which is 6, and comparing that to the corresponding side of triangle XYZ, which is 3. I could write that as a fraction, and I could reduce the fraction, which would give me 2/1 or 2. But when I change the order, triangle XYZ now is coming first. And triangle ABC is coming last. So that changes the way that I'm going to write the similarity ratio or the fraction. And notice that 2/1, 2, is not the same thing as 1/2. So these are two different numbers here. So the order in which the figures are being compared absolutely makes a difference when you're coming up with the scale factor or the similarity ratio. For the next problem, again, we're given a similarity statement. So we're told that triangle ABC is similar to triangle LMN. And then we're given some angle measures and side lengths, but I don't have any pictures. So the very first thing that I'm going to do is I'm going to draw a diagram. Maybe not drawn to scale. I'm going to then fill in the information that I'm given. So I know that the measure of angle A is 90 degrees, AB is 12 units, AC is 5 units, the measure of angle M is 15 degrees, NM is 39, and LM is 36. Find BC, LN, and all the remaining angle measures. Well, I know that if these triangles are similar, and angle A is 90, angle A has to be congruent to angle L. So angle L also has to be 90. I know that if the measure of angle M is 15, M corresponds with angle B. So angle B also has to be 15. And then in either triangle, I could use triangle sum theorem to figure out what the missing angle measure is. If this is 90, this is 15. This is going to have to be 75. C corresponds to N. N is also going to be 75. So that takes care of all the remaining angle measures, but I still have to find BC's length and LN's length. So what I could do again, if we're having trouble kind of figuring out how we're going to find these missing side lengths, what you could do is write down the extended proportion. Again, just coming up with the orders of the letters. AB corresponds to LM. BC corresponds to MN. AC corresponds to LN. That's how I came up with this. Then we could look at the diagrams to fill in the different measures. So AB is 12, LM is 36, BC, I don't know, but I know MN is 39, AC is 5, and LN I still don't know. So I'm going to pull the first ratio and the second ratio because I know 12, 36, and 39, and I can use this proportion to figure out what BC is going to be equal to. What I'm going to do first, though, is simplify 12 over 36 because I know that they have a common factor, and I'd rather work with smaller numbers. So I took out a 12 and a 12 from the top and the bottom. And we could cross multiply to figure out what BC is. You could also use equivalent fractions though. So like what do I have to multiply 3 by to get to 39? I had to multiply by 13. So if I multiply 1 by 13, I'll get 13. So I know that BC has to be 13. If you feel more comfortable cross multiplying, you can definitely do that. But I do want to point out that you could use equivalent fractions. So I'm going to then, in order to figure out LN's measure, I'm going to take the 12 over 36, which we already just simplified to a third, and set that equal to this third ratio. Because the last part of the problem is saying you need to find LN. That's the only thing we haven't found yet. And again, I can use equivalent fractions. If you want to cross multiply, you can. But I know to get from 1 to 5, I have to multiply by 5. So if I want an equivalent fraction, if I multiply the top by 5, I have to multiply the bottom by 5. 3 times 5 is going to give me 15. So the next problem is talking about, again, we are given similar figures. So the question first says, what is the scale factor of ABCD to QRST? So I'm going to take a look at the corresponding sides that come from the first two letters. So ABCD, I'm going to look at what's the length of AB. So that's 12. Because that's written first, I'm writing 12 first, and I'm going to compare that to QR's length, which is 6. We could also write that as a fraction, 12 over 6, which would reduce to 2 over 1, or 2. Next, it says find the value of x. So we need to figure out what x is going to be. So I know that from the diagram, x corresponds to BC. So x is the length of BC. I know that RS, the middle two letters, correspond to BC. So I'm going to start to build a proportion. And we just compared corresponding sides of AB to QR. And remember, in similar figures, corresponding sides have to be proportional or have equal ratios. So this is what I'm going to use in order to figure out the value of x. But again, I'm going to simplify 12 over 6 to work with some smaller numbers. If again you want to use equivalent fractions, I know to get from 1 to 4, I had to multiply by 4. So if I multiply 2 by 4, that's going to give me x's value, which is 8. If you want to cross multiply instead and solve, you can absolutely do that. Part C then says, what are the perimeters of each of these quadrilaterals? So the perimeter of ABCD, if I add up 12, 8, 16, and 10, I'm going to get 46. If I find the perimeter then of QRST, add up 6, 4, 8, and 5, I'm going to get 23. The last question says, what is the ratio of the perimeter of ABCD to the perimeter of QRST? So the perimeter of ABCD we just found to be 46. I'm going to compare that to the perimeter of QRST, which was 23. I could also write that as a fraction. And I noticed that the top and the bottom both have a common factor of 23. So if I take that out, I get the same ratio from part A. So the ratio of corresponding sides is going to be the same as the ratio of the perimeters of the similar figures. And that's what the next slide is talking about. It says if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So in the next example, we know that triangle ABC is, not congruent, similar to triangle DEF. If BC is 14 and EF is 35, and the perimeter of triangle ABC is 42 units, find the perimeter of triangle DEF. So I know that BC and EF are corresponding because they're the last two letters in the triangles. So I'm going to set up a ratio comparing corresponding sides. That ratio should be equal to the ratio comparing the perimeters of the similar figures. So the information in triangle ABC is in my numerator. So I know the perimeter of triangle ABC is 42. So the reason I'm putting 42 up top is because 14, which is a side length of triangle ABC, is also up top. So the information for DEF is going to be in the bottom. I want to find the perimeter of triangle DEF, so that's unknown. So I'm going to let that be X. What I'm going to do before I cross multiply, you could just go straight ahead and cross multiply if you want to, is I'm going to simplify this fraction because I know that 14 and 35 both have a common factor of 7. So now I could cross multiply. The numbers are a little bit smaller to work with. I could also use equivalent fractions. So I know that to get from 2 to 42, I have to multiply by 21. So if I do the same thing in the bottom and multiply 5 by 21, that would give me 105 in this position where X is. So I know that X would have to be 105, which is the perimeter of triangle DEF. And then the last page here says that triangle ABC is congruent to triangle DEF. Is triangle ABC similar to triangle DEF? Explain your answer. So again, to verify that two figures are similar, we want to first go through these steps. Are corresponding angles congruent? If the triangles are congruent, it does mean that corresponding angles have to be congruent. By CPC-TC. So yes, all corresponding angles are congruent. Are the corresponding sides proportional? So again, I'm going to use the order of the letters, A, B to D, E. I'm going to then look in the picture, find those side lengths, and reduce. I'm going to pick out the next pair of corresponding sides, which is BC to EF. And that's 7/7, which also reduces to 1. And then the last pair of corresponding sides would be AC to DF, which would be 6/6, which also simplifies to 1. Since they all simplify to the same number, yes, corresponding sides are proportional. So anytime we are given congruent figures, they are always going to be similar to one another, which is what we're going to conclude down here. So congruent figures are always similar. Similar figures, though, are sometimes congruent. Not all similar figures are going to be congruent. This pair of similar figures happens to be congruent, but some of the other problems that we were taking a look at, like in this example, these were similar, but they weren't congruent because they didn't have all the same side lengths. So that's why when we fill in the blank, we're going to use always here, sometimes here.